Hi. So in this question, we are taught to evaluate, and additional information that is given is that D, okay, D is a region. Uh, D is the region in the fourth quadrant. Okay, is a region in the fourth quadrant, fourth quadrant there. Okay, and it's between two interesting functions, which is x squared plus y squared is equals to 16, as well as x squared plus y squared is equals to 36. So it's between these two functions and is in the fourth quadrant. Okay, so what we mean by the fourth quadrant is this. Let's say we have that as our vertical axis, which is our y-axis, and we have our horizontal axis, which is our x-axis. So this right here is our y-axis, and this is our x-axis. So this is our first quadrant. Okay, this is our second quadrant, and this is our third quadrant, and this is our fourth quadrant. That's the one that we are talking about. Okay, so one thing that you are able to notice from these two functions is that these are actually circles. Okay, this is a circle of radius 4. Okay, so to find the radius, just say radius is equals to the square root of, in this case, 16, which is going to give you a 4. You do the same to say another r, which is a radius, which is the square root of 36, which is going to give you 6. So meaning this one has a radius of 6. Okay, so what it means is this. I can draw circles, and what you're able to observe about these circles is that they are centered at the origin here. I can draw the entire circles, but I'm more interested in what is happening, or what we have in the third quadrant. Okay, so let's go ahead and draw these circles. So I have my compass right there. I'm just going to reduce to just some uh, uh, random digit there. Okay, random length. Then I'm going to draw this as my 4. Okay, as my 4. So maybe from there to there, like that. Okay, so I'll have to extend this to put up a 6. Okay, um, just try to change the color. Okay, something like that. Okay, so this is what it means by the fourth quadrant. I could have chosen to extend this to be more like a circle like that, as well as this one, but we are not really interested in that. We're just interested in what is happening in the fourth quadrant. Okay, so and the reason why we are doing all this is that one thing that you can tell or observe about this question is that we are going to have to use the polar form of this integral for us to be able to evaluate it, um, because using Cartesian, I think that would be a lot of work to do. It would be a bit tedious compared to us using polar. Compared to us using polar form of this same double integral. Okay, so the reason why we have to sketch this, or it's interesting to sketch, or it's important to sketch, is because it gives you an idea of how you're going to be getting your limits. So in this case, the limits that I'm looking for r and theta. Those are the limits of integration that I'm looking for. So I'll have to do something here. I'll have to extend. I can pick any, maybe this or maybe that, as some kind of like a radius or something. But I observe to say whichever that I pick is still going to give me one and the same thing. Okay, so this is more like kind of like your R, but you're only interested in this part. Like you're only interested on that red part there. That's where our interest lies, and you're able to observe to say the radius is just more like in as much as it's like it projects all the way. Okay, it's just more like it's going to turn on or switch on at what, at 4. Okay, then we say less than or equal to x, not x but r, there we say r less than or equal to 6, and it's just this 6 right here. So this is from the equation x squared plus y squared is equals to 36 with the radius of 6, and this is from x squared plus y squared is equals to 16 with the radius of 4. Okay, so now we have our limits of integration in terms of r. Let's look for the limits of integration in terms of theta. Okay, so what you do is that there are two sets that you can use that can give you the same thing. Okay, so I can choose to say I'm going to start from, that is for the theta, I can just say I'm going to start from minus pi over 2. Okay, that's for my theta. Then I go all the way to 0. Okay, so remember to say this line right here, the one, the negative part of the y-axis, you can either indicate it as pi minus pi over 2, which is minus 90, or you can indicate it as 3 pi over 2, like that, which is 270. It's one and the same thing. Okay, so, and this one here, which is the positive part of the x-axis, I can write it as 0 degrees, or it can be 2 pi or 360 in degrees, then 2 pi in radians. Okay, so here how this one is going to be is that you can choose, you can use this, or you can use 3 pi over 2, like that, to 2 pi. So whichever that you use is going to give you the same thing. So I'm going to use one of these for the theta, then the other one, the other one you can try it on your own, then you compare your solution and mine, and I believe it's going to be the same. Okay, so let's go ahead and evaluate our integral, since we now have our limits of integration. So for the theta, let me use minus pi over 2 to 0. Then for the r, we have 4 to 6. Then our integrand there is e to the power 1 minus r squared. Then here we're going to have r dr d theta. Okay, so you can choose to use 3 pi over 2 to 2 pi. You can try that one out, then you see if you're going to get the same thing. Okay, so for this part here, what I've done is that since I have 1 minus x squared minus y squared, I can choose to write this as 1 minus open bracket x squared plus y squared, and we know to say this right here is equals to r squared. That's where this r squared is coming from. And for this part, always keep in mind to say, if you have, say, dy dx or dx dy, this is going to be written as r dr d theta. That's what it changes to. So over this area dA, it changes to that, because it was just more like dy dx or dx dy. Okay, so let's go ahead and integrate the inside part. So when you integrate this inside part, or the method that you can use to simplify your work is actually u substitution. You're going to let u be equals to 1 minus r squared, meaning your du will be equals to minus 2r dr. You observe to say your dr will be equals to du over minus 2r, like that. Okay, so this now becomes from minus pi over 2 to 0. Okay, so observe to say I have like minus 1 over 2 from this portion here. I can just write it on the outside, since it's a constant, minus 1 over 2, evaluating from 4 to 6, and here you have e to the u. Okay, then you have r. Then when you have dr, you have to put du over r. I was supposed to say du over minus 2r, but I've already put this part, the minus 2 out, the minus 1 over 2 outside. Then one thing you observe is that this and that can cancel out. Okay, so you can go ahead and do the integration. So this will be from minus pi over 2 to 0. Then you have minus 1 over 2. So integrating this one here, you still get the same thing. Okay, that's the most interesting part about exponential functions. You still get the same thing. So, and I'm just going to convert it just at this stage. So instead of me writing e to the u, I'll write e to the 1 minus r squared, and you're evaluating from 4 to 6. Okay, and you still have your d theta outside here, like this. Okay, so what does this now become? So minus pi over 2 to 0. So this is minus 1 over 2, like that. So when you evaluate Okay, when you evaluate, plug in 6 and plug in 4, this is going to be e to the power minus 35 minus e to the power minus 15. How am I getting this? It's very simple. When you plug in 6 here, this is going to be 36. Then 1 minus 36 is minus 35. When you plug in 4, this is going to be 16. 1 minus 16 is minus 15. You see, you have your d theta there like that. Okay, so one thing that you're able to observe is that everything that you have here is but a constant. Okay, that's a constant, so you can actually pull it outside. So this can be written as, and actually I can also take care of this negative by distributing it inside, and by doing that I'm going to have like 1 over 2 outside. Then in the brackets I'm going to have e to the minus 15 minus e to the minus 35. Okay, then integrating from minus pi over 2 to 0, then you have d theta there like this. And when you integrate this part here, you observe to say that's just going to be theta. So you have like theta moving from uh, minus pi over 2 to what? To 0. So this would be like 0 minus, open bracket, minus pi over 2, which gives you pi over 2. So at this point here, one thing I get is, I observe that I get pi over 2. Hence, to finish this up, the final solution is just 1 over 2 by pi over 2, you get pi over 4. Then in the brackets, you're going to get e to the minus 15 minus e to the minus 35. And this is your solution. You can try out using those limits moving from 3 pi over 2 to 2 pi. You are still going to get one and the same thing. And this is how we answer this question. Thank you very much for watching, and we'll catch you in the next one.